Hello, everybody. I'm Alexy Khrabrov, the founder of the Community Research Center for Reliable AI at Northeastern University and head of community at Lake Sale. And here I am in Paris at the International Science Council and CODATA office. And with me, we have Slava Tikhonov, who is the head of AI at CODATA. Welcome, Slava.
Thank you.
Explain to us what the council and CODATA are.
Yeah, so we're a non-profit organization, and basically we're advising to political bodies like governments, presidents, organizations like World Health Organization, United Nations. We're advising on policies on data and artificial intelligence and other stuff.
And this is supported by the government of France.
Yeah, that's right. So we are here also in France, and yeah.
But you operate globally, so you operate all across Europe and around the world.
That's right, yeah. So yeah, we are based in Paris, and our global activities include Latin America and Australia, other continents, like we have a lot of activities in Africa as well.
Mm-hmm.
And yeah, we are basically like global player advising on global policies.
Great. And before that, you were a researcher at the Royal Dutch Academy, and you were one of the authors of Dataverse and Croissant and semantic Croissant standards and CDIF. Right? So we're going to discuss all of this. We see it as a semantic layer for AI, as AI navigation, as you call it.
That's right. So it's a bit more complicated because what we're doing now. So first, we created navigation layer, which is Croissant for machine learning, standard originally initiated by Google. And now we are building an extension, and this extension includes also cross-domain interoperability framework, which is what we use for semantics. So basically, you can see Croissant as a navigation device in your car. So if you want to drive somewhere, you have to select city and after street name and after building number. And we do exactly the same for AI. So AI knows where to find resources. And as soon as you arrive, you have to ask what is available around. So this is about relationships. And cross-domain interoperability framework, CDIF, allows to describe all these relationships and define as variables. So very detailed variable layer, including units of measure and properties, hierarchies, and all related information. And on top of that, we also have actionable policies. So we are using old standard called ODRL, Open Digital Rights Language. And basically, we can put all stuff together with decentralized identifiers, DIDs. And they also have verified credentials. So we can see from whom is coming every kind of bit of information. And we also we have provenance, we have basically logs, and all this information is completely transparent. So we can build responsible AI applications, and they can basically be used for any kind of research activities, and they can support any kind of activity related to AI, basically. Yeah.
No, this is great. So this a lot of information. So let me unpack it a little bit and kind of zoom in. So first of all, we're talking about data quality, and a lot of folks who are doing agentic AI. I'm in Bay Area, and we have agentic frameworks. 5 meetups a day. Mostly they're talking about agents interoperability. They talk about MCP and tool calling. So they talk about the functional size of agents. Where do agents go? What do they do? And it's taken for granted that the data is there. It's an elephant in the room, because if the data is not good, if the data is of questionable provenance, and the agents just go and find it without checking, they will produce garbage. So we focus basically here on the data quality. So all of the Croissant, semantic Croissant, DID and ODRL, all these technologies come together to, first of all, annotate data sets, so we know exactly what is the meaning of each column. And CDIF allows you to say, if it's a number, what is it? Is it a Kelvin? Is it Celsius? Who produced the number, right?
Yeah.
Did it randomly appear? Can it trust this number? You need to know which lab produced the number. You can't just take numbers for granted. If it's financial data, they should come from trusted exchange if you're going to act on this data. So we're basically talking about data quality, and I think Slava is one of the few people who actually consistently allows kind of to build this whole navigation layer for data, right? Because once you have the data, then then agents can find the right data, but nobody really focuses on making sure the data is correct. So this is huge. And both DID and ODRL are W3C standards, right?
That's
so
right, yeah.
they exist for many years. DID is implemented by Microsoft Azure. You can just go and and use DID primitives. It's Hyperledger. You can get DIDs on any Hyperledger compatible network. So if this is established standard, this is not something new. This is basically, and semantic Croissant has been developed by Slava and other folks. So this is a set of technologies which is trusted, which is working, right?
Yeah.
So in all of this exists. So this is not a white paper.
No. That's really true. So what we do now, everybody is moving forward with agentic AI, and we are basically trying to align our infrastructure with modern direction. And what we see now happening in Silicon Valley, so people are building applications on cloud, on Codex, so they're using different tools, different services, different applications, and at the same time, we don't see responsible AI. So basically, it's not reproducible, and you don't know where, what you are building is based on completely wrong code or wrong data. And we are trying to bring this layer of trust. We are building that by basically communicating to people responsible for standards, and they're working together to make definition for every variable. So to make actually this definition available for every model, so not only for Google, for Anthropic, so it should be like a layer of trust which is distributed, and you can connect, you can get this definition of variables, and this is how you can connect to like global infrastructure and reduce randomness.
Right. So basically, this technology allows to avoid non-determinism, and so let's zoom in on this a bit, right? So one of the things which I was really impressed by that you do is you basically wrap a prompt in a DID, because DID is an ID which can have an XML payload, and so you can attach prompts and skills. And if you want to, you can encrypt them, and then you can let middleware like Llama decrypt them, right? So
that's right,
it's easy to build the infrastructure where, and because the DID is a global URI, then middleware can actually find it, right? And if there is a ODRL and public key infrastructure, it can actually decrypt it as needed and execute it. So that's what you've done with Llama. And you achieve the high speed up because you're imposing determinism by doing this. Can you explain a little bit how that happens?
Yeah, so what we're doing, we're trying to kind of freeze vectors, they call tensors, inside of LM models, and we're introducing ground truths. So basically you have a pair, question, answer, and it's getting a digital signature, and it's been also signed digitally. So you have owner and you have person, you have human who is behind.
Right.
So you know who is responsible, right?
Right.
And as soon as you have this key and value pair, it will become fully deterministic. So as soon as you'll ask this question, and it will always be the same answer. And basically that means that you don't have to do compute. Like, for example, if you're using local AI, local inference engine like Llama, VLM, so it runs with speed, let's say 50 tokens. But this is because they have to do compute. So you're asking question, there is a very complicated process behind, and it's basically slow, right? And what we do, we are kind of pre-caching everything, but this is not real cache. So we have the whole vector. And it's also, it's not cache in a traditional way, so we can also define threshold. So like if question, let's say 95% is already being answered, so we can also take like similarity measure. So you don't have to compute again, so you can just pick up all these pre-computed vectors already and use these to answer question, and only compute like 5% what we don't know. So it's also a very significant speed up of the process. So instead of using like time, waiting for let's say 10 seconds for answer, it will be probably 1.
Right.
Because it's already like kind of pre-cached.
Right.
And what is really important, so as soon as it's being computed and a human agrees to put a signature, to put its name, so you can also distribute this knowledge. So you can just export this, the whole tensor. It's around, well, in general, 50 kilobytes file. And you can package and you can transmit to another inference engine. You can just run it, ask the same question, and it will be the same speed and the same answer. So you're basically turning you're converting from non-deterministic answering machine to fully deterministic, where F is predefined. It's coming from source that you can trust, and this is really important. And I mean, for cross-domain interoperability framework, where we're supposed to deliver some solution that will allow to convert, like to reuse data in different domains. Let's say you are doing something in physics and you want to just to repackage the same variable in different standard and provide to another domain, so they can also connect and they can use that. It should be possible because this is kind of universal distribution mechanism. And for AI, I think this is exactly what we need right now, because LMs are getting crazy with all this randomness, and we can't just rely because we can't reproduce results.
It's reproducibility is the hallmark of science. Non-reproducible things are not science, and you're basically bringing this back into the domain of science, which is incidentally the mission of CODATA, and which is great, but it's also required by any business. So I want to emphasize a very important point here. So all this is happening on the CPU, right? The cached values are being obtained from the middleware, right? And so you demonstrate 1,000,000 tokens per second, because you effectively and you're avoiding GPU whenever possible. So that means enormous savings on compute. It means moving back to CPU infrastructure and right, for reliable kind of reproducible data. So anything which you need to be reproduced will be reproduced from CPU. It was before computed on GPU once, which is very, very important given that shortage of compute and waste of energy and money.
That's completely correct. And what is actually happening right now? So we started to produce CDIF variables, and we do it once, and we're getting registry of variables, and after we can just redistribute everything without running compute again.
Right.
So like you said, we are moving world from GPU computations, which is very expensive, requires a lot of resources, and it's long process. Where we are moving to completely deterministic model, where everybody can just download updates from us and run on own computer. Doesn't matter. It can be a really primitive computer. It's actually, because it's kind of pre-computed, you can also use really small models, which you can run on your mobile phone, right? And you don't need like powerful computers to do that anymore. So basically, AI is becoming really democratic, and everybody, I mean, every researcher, every person on Earth can just install it and run, right? And the same goes for agents. As soon as we have this ground truth, which is distributed, and we also have complete provenance information. We know our region. We know who's responsible for that. We can just plug in all these agents, and they can do a reliable job. And we can also establish reliable baselines, which is extremely important. Everybody's talking about baselines, how we are going to test what agents are producing, if they're working together. So we can also like put DID, decentralized identifiers, on every agent, produce verified credentials, and we can see what every agent is basically contributing. And if something goes wrong, you can go to a logbook, and you can actually find who from agents not getting enough data, or is getting wrong information, and from which source. Which is completely.
So all the bad agents can be fired automatically if they're not producing properly.
I really like the idea. Also, not technically not fire them, but basically they should be gone with pension. So
that's right.
We can kind of ask AI. Archive. So we can also ask AI like re-implement. So this agent has already collected a lot of knowledge. So now we can package knowledge. We can also see. We can check what is valid and what is not valid anymore. We can repackage and run new agent, basically like having knowledge from previous one.
This is Europe. We cannot just fire agents. We have to upskill them and give them a new job, so they can actually.
Yeah, and that's right.
Right. So I want to focus also. I think this is super interesting. So you talk about drift, right? So when you say basically non-determinism, it also means that if something does change, then you can measure the difference, you can detect it, you call it basically drift. And I think one way it can be implemented is European DID is not only the questions, but also the answers. So now you have a question and answer pair which is timestamped and versioned, and we know exactly which version of the agent, which version of the LLM, which version of the whole infrastructure.
Which version of human? Because
Which version of human? I mean, hopefully, I mean, we cannot measure, but we know the human identity of the user, right? So now we have basically complete kind of traceable provenance of the whole tool chain that produced the Q&A. So talk a little bit about how do you detect drift? What if the LLM has changed, right? And how do you see what has changed?
Yeah, so drift is a very well-known problem in knowledge engineering and knowledge organization. So knowledge is completely, so it's not static, it's moving. It's moving in time and space. So let's say if you want to understand how people used to think about like nuclear physics 100 years ago, and you want to get opinion of Albert Einstein, so you'll get it from his book, right? So this knowledge we can just capture, we can package, and we can put also in LLM, and we can digitally sign it. So it knows that this is not up-to-date knowledge, it's like from 100 years old.
Right.
And by using that approach, we can also put like different timestamps and find different books, and we can see how knowledge was developed in time, which is kind of unique because I don't think someone has created something like that before. And now we have a really unique opportunity basically to see all this drift, how knowledge is developed in time and how we can reuse it. You know, like
so
how to track this delta.
So let's look technically. So let's just start with Newton, right? So Newton, you know, published Principia Mathematica and put them, you know, you can scan it. It's a beautiful, I have like the reproduction of the original edition in Latin. Beautiful, you know, volume. So you scan it, you put it in LLM. Now you got, you know, Einstein. So it has a different views of physics. So how would you get both answers about something and compare?
So this is where AI agents actually doing job. So basically, we're asking different agents. So let's say one agent is already responsible for name entity recognition. So it's basically trying to understand where a person is being mentioned, what kind of dates available, and what kind of organizations, and you know, all these entities, right? And basically, it's kind of foundation of knowledge graph. So that's something we can already capture, and we can transmit this information to another agent, which is kind of linking all this information to available knowledge. And knowledge is being stored in knowledge base. So it's not. This is something different from people did with LMs. So like standard approach, let's capture all knowledge. We'll put it together. We'll build a new model.
We'll train
LM, yes. So instead, what we can do, we can just put identifier on every claim, and it will become traceable. So you will see from which source it's coming, and who actually created this knowledge, and what kind of attitude it has. So all this kind of information is traceable, right?
So we have a knowledge graph next to LLM, and for reasoning. And so, by the way, I must mention that one of my professors at the University of Pennsylvania and the region of University of Edinburgh, and he returned there, Professor Mark Steedman, one of the world's top experts on knowledge graphs. He basically was advocating that architecture for many years, and he and his students published a paper proving that LLM is not capable of reasoning or entailment, right? So and knowledge graph is something that you should be doing. So you're basically doing the same architecture. So you're extracting knowledge from LLM, and you stamp the claims, you know, the questions, right? So now you know that LLM one believes, and you put it in the knowledge graph, right? So
that's right,
so you have like a concept in physics, right? Like what is force, and you put it like LLM, you know, Gemma 4 believes that Newton describes force as this, and you put it in the knowledge graph, right? Under force, and the reference will be to Newton. And now you question something about force in Einstein. Are you creating different node? Are you comparing the force node with that? Like, talk me a little bit through how do you see that drift, right? Like, how do we know what Einstein said about force, which is now changing the idea?
This is exactly where archive is very useful, because basically if you have all this knowledge in knowledge graph, it's archive. So it's digital archive. And instead of like packaging all stuff in a model, you can also query it, right? It's using modern languages like Sparkle, and we have another agent, and it knows how to operate Sparkle. It
Right.
was trained on that.
Right.
So as soon
Once
as
it's already in the knowledge graph,
Yeah.
you can work or cipher or whatever you want.
yeah. So basically, you ask a question. It does this analysis.
Yep.
It's recognizing a topic. It's doing an entity recognition, and it's querying graph to see what is available.
Yes.
Of course, like part of information, it could be kind of contradiction also. It's basically extracting all facts, and this is where we have to rely on LM models and on knowledge which is already been packaged inside of LM, because it should know how to distinguish all these relevant facts from irrelevant facts. But at the same time, if you have new knowledge coming in, you can also get it from knowledge graphs, like to confirm some claims, to find evidence. So this is much more powerful model, because it's very, very expensive to train new model.
Yes.
So instead, like packaging everything in one big file, you're basically connecting to distributed system, and this distributed system is alive. It's like every second new knowledge is being captured, processed, and stored, and it's available. So as soon as you are asking questions like what is kind of new information you have right now, right?
Yes.
And we can also think like about knowledge is moving in time and space. So like in different countries, the same fact can be understood differently.
Right.
So now you have perfect opportunity just to ask how it's been understood in US,
Right.
and in China and Europe.
Right.
And you can see from different sides. So the same.
Right.
And if you'll ask LM right now, like go to ChatGPT, probably you will get only approximation, right?
Right. I mean, actually, it's funny because if you ask, models from different countries about politically sensitive things in these countries, they will give you politically filtered answers.
Yeah.
So some of the answers will be actually incorrect, right, or massaged according to what's going on. But I think it just points to a bigger problem that LLM is an average answer as of today, right? So LLM is actually not versioned. The current architecture of an LLM doesn't let you say, okay, what did you answer yesterday? What would you have answered to me before the date X when some event happened? LLM is not made currently at all, right? And knowledge graphs, you can, it's interesting that knowledge graphs are also inherently not versioned. It's very difficult. So people have to manually version them. So if you want to implement temporal change in a knowledge graph, you have to think of this yourself. You have to attach timestamps to every update, create basically like lists of values instead of one. But you can do this, right? Like this is and also it hints at the fact that we need this semantic layer as separate, but we need it for multiple reasons. We need it for caching and performance. We also need it for the archival purposes, and for detecting drift, right? So query graph kind of is this, right? Like it's a set of technologies. So by the way, everything we describe is on the website querygraph.ai, and Slava's posts are there, and some kind of general information, links to the open source, because all of this is actually built, right? This is not a white paper.
Built and open, yes.
Built in
and ready to use.
And can be tested. And then maybe I'll just wrap up with, so we are here right after the GoSim Paris conference. GoSim is the global open source AI event, basically put together by multiple companies around the world, held in Station F, the iconic AI capital of Europe in Paris. And so we just seen presentations from some of the leading companies and model makers. And we talked about semantic layer to many of them and received very positive response. Maybe you can talk a little bit about folks who do Open Compute at the Beijing Academy of Artificial Intelligence, and what is the synergy between Open Compute and kind of semantic layer?
Yeah, I was very impressed by the level of presentations at GoSim, and it's unbelievable. And I'm also quite impressed what China is doing, because it's supporting open source, open knowledge, and basically what I learned now, there is a new project called FlagOS, and it's basically they're building an operating system where all knowledge is free and kind of distributed.
Yes.
So from one side, they have support of different chips. So for example, it's not only NVIDIA, you can also run your software, your models on Chinese chips, on Korean chips. Like basically they have, I think, 30 different chips already supported. That also means that you can connect your own laptop. So it doesn't matter if it's Dell or if it's someone else. So HP. Apple, so they don't care. So basically, you can just run the whole operating system, and you can get access to shared resources. So you can also kind of create computational resource, which is enormous, and you can do it for free, basically, because all people already have these laptops, and it's kind of, creating shared memory and shared storage, and you can just use it to do like serious stuff. And you don't even have to fund the creation of new data center, which is like big deal right now, and everybody's running out of the compute. So now, let's say if some research institution wants to do like serious compute, so they can install this software, they can combine all resources together inside of one institution and do that stuff, which is unbelievable,
Yes. So it's open compute for open science and open source AI basically. And I think the semantic layer we're talking about can be extremely useful because people should be able to find the data sets they need, and they should be trusting. And because it's led by scientists, obviously, it will be very useful for scientists around the world. And scientists are usually the ones resource constrained, right? They cannot pay for huge data centers. So I think that's a really good spirit. So that community.
I would say what is also very important, and we're also contributing to this development, is support of multiple languages. So as soon as you have AI, which you can trust, so you can also get a translation of the same terms on same vocabularies in different languages. So you know that temperature is defined like that in Chinese, in French, in other languages, and you can reuse that. So it's basically always the same definition, and it knows what kind of units of measure, and it can control that.
Yes.
So as something goes wrong, it can understand that temperature is measured from this limit to this, minimum to max, and it can immediately this policy, like you can define also digital policy, it can immediately alarm that something is wrong. And as soon as you have this enormous infrastructure like open compute deployed everywhere in the world, you can just send signals, and this is how I think world will be moving in the future with global collaboration.
Okay, and so maybe finally, I just want to kind of propose that this whole setup can be put inside of a company, right? So if you have a corporation, you have different data sources, different departments. You need, first of all, to make sure that all the data inside the company is in a trusted format. It's basically explainable for the agents which are running business inside this company, that the computation is efficient. So everything we described can be basically an enterprise data platform for AI, right? And so the AI navigation will happen inside of this company, and ODRL level will be basically used to precisely define which employee, which department have access to which data, because the data in this case encapsulates the whole business knowledge of a company, right? Like these are the prompts and skills which will never be shared outside because they basically express what the company is doing, how it's making money, how it's keeping secrets, how it's doing innovation, right? So if it's done in business context, right, you need to basically have very tight control, right? Because you talk about value, and here you can help impose it on agents automatically. The IDs let you trace. So if something goes wrong, right, performance drops, right, profits drop, something happens, breach of privacy, PII, you can always track which agent accessed what, which promise was used, which answer was received. And the drift which talked about is very important because it can help business understand if the performance is changing, why my e-commerce model is not performing as before, because something has changed in the underlying LLMs being used, and all of this can be used with the open source LLM run on premise. So all of this can run inside of data center, right? And so if you suddenly, let's say, try
even without internet connection.
Even without internet, so it maybe factory automation, right? And so if something went wrong because, for instance, a new open source model was used,